Usually when we talk about, you know, sending a quick text or asking our phones to summarize an email, there's this implicit, almost invisible transaction happening. You type the prompt, hit send, and for a fraction of a second, your private thoughts, your work emails.
Sometimes even your like snarky comments about your boss.
Exactly.
Yep.
All of that gets beamed up to a massive server farm, thousands of miles away.
Yeah, it goes right into the cloud, gets processed by a giant corporation's algorithms, and then boom, the answer comes back.
Right.
And the sheer speed of modern internet connections makes it so seamless that we completely forget the transaction even took place. We treat these tools like they're living inside our devices, but they're really just looking through a window into our lives.
But then you step into the world of truly local, like completely private artificial intelligence, and suddenly that whole transaction is just flipped on its head.
Oh, terrible.
We are looking at a technological landscape today where your data never actually has to leave your desk. So welcome to the deep dive. If you are a learner who loves exploring the cutting edge of tech without getting bogged down by the jargon, well, you're in the perfect place.
Absolutely.
Today's mission is to break down a pretty incredible 2026 technical blueprint created by a tech educator known as OscarAI. And this isn't theoretical stuff. It's a highly practical, step-by-step guide on how to build your own 100% private, entirely local, and uncensored AI assistant.
Basically, we're talking about building your very own personal Jarvis.
Right, your own Jarvis. Because the tech landscape has fundamentally shifted by March of 2026, hasn't it?
Oh, massively. For years, the prevailing narrative was that you needed the processing power of a minor nation state just to run a high-level language model. But this blueprint proves that's simply no longer true.
Yeah.
It sets up this dream scenario right from the jump. Imagine just sitting at home and asking your phone, hey, can you summarize this email from my boss and draft a sarcastic but professional reply?
Which is the dream, right?
Exactly. And the assistant does it instantly. But here's the kicker. Not a single byte of that data ever went to OpenAI. It never went to Meta. Google didn't see it. The entire thought process happened entirely inside your own hardware.
Okay, let's unpack this, because before we get into exactly how to build this private Jarvis, we really need to establish why tech enthusiasts in 2026 are just completely abandoning these massive cloud AIs.
Yeah, the why is super important here.
Right. And looking at the source, the core drivers are privacy, escaping endless subscriptions, and honestly, the sheer hardware capability of modern devices. Relying on cloud AI is basically like having an incredibly brilliant personal assistant who happens to secretly gossip about your private life to a massive faceless corporation.
That is a brutally accurate analogy.
Like, sure, they do good work, but they are literally making copies of your personal journals, your financial spreadsheets, your confidential work communications.
Right, whereas local AI is like having that exact same brilliant assistant, but they are locked inside a soundproof vault inside your own house.
I love that.
They work only for you, and nothing they see ever leaves the room. What's really crucial to understand about this 2026 mindset is that privacy is, well, it's no longer viewed as a luxury.
Right.
And it certainly isn't just for the paranoid anymore. It has become a baseline standard for anyone who understands the actual value of their personal data. Outsourcing processing to what the source calls suspicious clouds is just an unnecessary risk when your own hardware can do the job.
Plus, the subscription fatigue is entirely out of control. We're all so tired of paying $20 here, $30 there every single month just to access a tool that might change its features or hike its prices tomorrow.
Oh, absolutely. It's exhausting.
So we're really transitioning from the philosophy of renting intelligence to owning it. You pay for the hardware once, and the intelligence is yours forever. So if we want this vault assistant, we need to figure out what actually powers it, right? Like, what is the engine running this thing?
Well, the undisputed king of local large language models, or LLMs, is a tool called Ollama. Ollama is essentially the engine that democratized local AI.
And it wasn't always this easy, right?
Not at all. Before tools like Ollama, getting a model to run on your own machine involved, navigating complex Python environments, dealing with broken dependency chains.
The total nightmare.
Yeah, spending hours troubleshooting code just to get a basic text prompt to work. But Ollama reduced all of that friction to near zero. Installation now literally takes less than 5 minutes.
It's actually absurd how easy it is. According to the guide, on a Mac, Windows, or Linux machine, it is a single command line. You open your computer's terminal, paste in a line starting with curl, hit enter, and you are done.
That's it.
It downloads and installs the entire engine in the background, but, an engine needs fuel. It
Yeah.
needs the actual models, the brains to function.
Exactly. And the blueprint provides a deeply detailed snapshot of the top models dominating the landscape in March 2026.
Let's hear them.
So for top-tier reasoning and multi-language support, Quinn 3 is the top recommendation. Specifically, they point to the 72 billion or 32 billion parameter versions.
Okay.
Quinn handles logic by structuring its internal data processing to heavily weigh cause and effect relationships, which makes it incredibly sharp for complex problem solving.
Nice. And what about a good middle ground?
For that, you have Meta's Llama 3.3, specifically the 70 billion or 8 billion versions. Llama 3.3 is positioned as the perfect balance because its training data was aggressively curated for efficiency.
Right.
So it gives you this excellent mix of speed and high-quality conversational outputs without, totally hogging your system's memory.
And for the really heavy lifting.
And then you have DeepSeek V3 and their reasoning model, R1. These are just absolute heavy-duty powerhouses for coding and complex mathematics. And rounding out the list, we have Mistral Nemo and Google's Gemma 3, which are noted for being fast and surprisingly intelligent for their size.
Okay, hold on. Wait a minute. These models sound massive. You're casually throwing around phrases like 72 billion parameters or 70 billion parameters. I need to stop you there.
Sure.
What actually is a parameter? Because these numbers sound insane. Do I need a multi-million-dollar server farm in my garage just to run this stuff?
What's fascinating here is how parameters actually function. Think of a parameter like a synapse in a biological brain. It is a connection point between different pieces of information.
Okay, a synapse. Got it.
Right. So a model with 8 billion parameters has 8 billion little connection points, helping it decide which word should come next in a sentence based on the context you provided.
Wow.
A model with 72 billion parameters has vastly more connections, meaning it can understand deeper nuances, more complex logic, and richer context.
Yeah.
But to answer your question, no, you do not need a server farm.
Thank goodness.
Now, running a massive 70 billion parameter model at high speed does require serious hardware, like a top-tier desktop with multiple graphics cards. But the crucial takeaway from this 2026 blueprint is that you don't have to run the biggest models to get incredible results.
So someone with just a normal everyday laptop isn't left out of the revolution?
Not at all. The smaller models, the 3 billion to 8 billion parameter models like Llama 3.38b, can run beautifully on modern standard laptops.
That's amazing.
Yeah, the hardware has advanced so much that these 3 billion to 8 billion parameter models can even run decently on powerful cell phones. The architecture of the chips inside our devices has evolved to handle these neural network computations natively.
That is just mind-blowing. The brain of an AI that rivals what we used to access only via massive corporate data centers is now literally running locally in your pocket.
It really is.
Okay, so let's say I have this powerful AI brain quietly humming away on my computer's processor. That's great, but it's totally useless if I can't actually talk to it. Like, am I just typing code into a blank black screen? How do we put a face on this thing?
Right, you need a user interface. And the guide says you have two main pathways for bringing your local AI to life. It's essentially a choice between a passive interface and an active agent.
Okay.
Option A is Open Web UI. Now, this is installed using something called Docker.
Docker is basically a digital shipping container, right? Like, it isolates the software so it runs smoothly without messing up your computer's core system files.
That is the perfect way to describe it, actually. It contains the environment so you don't get messy software conflicts. And Open Web UI gives you a highly polished interface right in your web browser.
So it looks familiar.
Exactly. If you have ever used any of the major cloud-based AI chats, you will instantly recognize it. It looks and feels the same. But because it's local, it has some incredible features. It supports multiple users on your home network. It has image vision, meaning you can show it a picture, and it understands the contents, and it supports ARG.
Okay, RAG stands for Retrieval Augmented Generation, and this is huge. In simple terms, it means you can securely upload your own private documents.
Right. Highly sensitive stuff.
Yeah. Let's say you have a massive PDF of the IRS tax code, or your company's proprietary financial spreadsheets, or even your private daily journal. You drag and drop those files into Open Web UI. The AI reads them, indexes them, and can answer highly specific questions about them.
Yeah.
And because it's local, you are doing this securely without ever sending those files to the internet.
Exactly. So that is option A. Option B is a tool called OpenClaw, which came out incredibly strong in 2026. OpenClaw changes the paradigm from a passive chatbot to an active assistant.
That's an agent.
Yes. It doesn't just give you a chat window on your browser.
Hmm.
It connects directly to your real-world messaging apps like WhatsApp, Telegram, Slack, or Discord. It uses external tools.
Oh, wow.
Yeah, it doesn't just sit there waiting for a question. You can ask it to actively search the web, write and send emails, or manage your calendar directly from your WhatsApp chat.
I really love this distinction. I mean, option A, Open Web UI, is like having an incredibly smart encyclopedia sitting right on your desk. It knows everything, including your private documents, but you have to go to it, open it up, and ask it a question.
Right.
But option B, OpenClaw, is like giving that encyclopedia a smartphone and having it text you flight options and calendar updates while you're standing in line at the grocery store.
That's a great way to look at it. And the trade-off between the two highlighted in the source is very clear. Open Web UI is the undisputed king of simplicity. You set it up, and it just works.
Which we all appreciate.
Definitely. OpenClaw, on the other hand, requires significantly more initial setup to connect all those external tools through various API keys and webhooks. And because it is performing complex, multi-step agentic tasks, like searching the web, reading the results, and then formatting a message back to your Telegram, it actually requires stronger hardware if you want fast, fluid responses.
Well, yeah, if it's acting as a bridge between your local machine and the entire internet via your WhatsApp account, it's obviously doing more heavy lifting.
For sure.
So let's say you've done the work. You have your OpenClaw assistant connected to your Telegram. How do you make sure it doesn't sound like a boring, sterilized corporate robot? Because the major cloud models are heavily filtered by their parent companies to be universally polite and, frankly, totally devoid of personality.
And this is where the uncensored and customizable aspect of local AI really shines. You can fundamentally alter the AI's personality using a model file.
Or a model file.
Yeah, a model file is essentially the foundational rulebook, or like the DNA you inject into the AI before you even start talking to it.
Yes, and the OscarAI blueprint gives this incredibly specific, joyful example of a model file. They create an assistant named OscarBot.
Oh, I love this part.
Right. In the system prompt, which are the core instructions, they don't just ask it to be helpful, they instruct it to be a sarcastic but helpful assistant. They specify that it should speak in neutral Spanish, but include specific paisa touches when it feels like it, originating from Pasto, Colombia.
That level of detail is amazing.
They literally write into its core code. You solve real problems, you don't give boring corporate answers.
And the technical mechanism making that personality shift possible is tied to a specific parameter you set inside that model file called temperature. The blueprint shows them setting the temperature to 0.8.
I've always wondered about this. What does adjusting the temperature actually do to the brain of the AI?
Temperature controls the model's randomness, which we perceive as creativity. When an AI generates text, it is essentially calculating the mathematical probability of which word should come next.
Okay.
If you set the temperature to 0, the AI will always pick the absolute most probable next word. The result is very predictable, very dry, and very literal.
So boring corporate robot.
Exactly. But pushing the temperature up to 0.8 forces the AI to occasionally pick less probable words. It introduces a calculated amount of chaos, allowing the model to take creative liberties. You absolutely need that higher temperature if you want the AI to successfully mimic the nuanced slang and sarcasm of conversationalists from Pasto.
That makes so much sense. So you have this brilliant, sarcastic, entirely private assistant living on your laptop, managing your calendar, and reading your tax documents. It sounds like absolute utopia.
Yeah.
But yeah, we need a reality check here. Building this Jarvis is not pure magic. There is real-world friction.
Oh, definitely.
The blueprint lists 5 major hurdles to running this system. Let's tackle them. Hurdle number 1 is hardware, which we touched on a bit. Big models demand massive graphics processing units.
Right. And the practical solution the guide offers is to simply scale down. Stick to the 7 billion to 14 billion parameter models. They are highly capable and fit perfectly into the memory constraints of a modern laptop.
Okay, hurdle number 2 is speed. If you don't have a massive GPU, running even a 7 billion parameter model locally can be painfully sluggish. Like, it might type out one word every 5 seconds.
Which nobody wants.
Right. But the solution introduced here is a process called quantization, specifically using formats like Q4KM or Q5K.
Quantization is a brilliant piece of computer science. Neural networks natively operate using high-precision floating-point numbers, usually 16-bit numbers.
Okay.
These take up a lot of physical memory and require immense computational power to multiply. Quantization mathematically compresses those numbers into lower precision formats, like 4-bit numbers. It is essentially rounding off the long decimal points in the AI's brain.
Here's where it gets really interesting, you know. You are taking this massive, sprawling network of billions of parameters and shrinking it down, compressing it into a laptop-sized file.
Yeah.
And the incredible part is that the blueprint proves you experience almost zero loss in the actual quality or intelligence of the output. It's like zipping a massive video file, but for intelligence. You drop the file size by 70%, but the AI is still just as smart.
Exactly. It allows you to run models that fundamentally shouldn't mathematically fit on your machine at incredibly fast speeds.
Incredible. Okay, what's next?
Hurdle 3 is hallucinations. Because even in 2026, AI still makes things up. When it doesn't know an answer, it tries to predict one anyway.
So how do you fix a liar that lives on your hard drive?
You use a combination of constraints. First, use that RGAG feature we discussed earlier. Ground the AI in your actual uploaded documents so it has hard facts to reference instead of relying on its generalized training data.
Makes sense.
Second, write tighter system prompts in your model file demanding accuracy. And third, drop that temperature setting. If you need pure facts for a legal document, lower the temperature down to 0.6 or lower to rein in the creativity and force it to pick the most probable, safe answers.
Good tip. Okay, hurdle 4 is energy. And this one blew my mind. If you actually decide to build a massive desktop rig with a top-of-the-line RTX 4090 graphics card to run the biggest models, that single card can suck up 450 watts of power at full throttle.
Yeah, that's a lot of juice.
That is the equivalent of leaving a small space heater running at full blast under your desk just to ask an AI to proofread an email.
Which is incredibly inefficient for basic daily tasks. The solution the guy gives is modularity. You swap your models based on the task. Use a tiny, energy-efficient 3 billion parameter model for simple questions or basic summarization, and only spin up the massive, power-hungry 70 billion parameter model when you're doing complex software coding or heavy data analysis.
Smart. Okay, we arrive at hurdle 5. Maintenance. The AI landscape moves at breakneck speed. New, smarter models drop every single month, and honestly, this is where I start to panic.
I can understand that.
The blueprint says the solution is active participation. You have to subscribe to model libraries, track updates, pull new models via the command line, and manage your Docker containers.
Hold on. I have to update my own libraries.
Yep.
Troubleshoot software dependencies. I am already exhausted by subscription fatigue, but now you're telling me I have to be my own IT department. I barely have time to check my email, and now I'm supposed to manage server infrastructure and pay massive electricity bills just to keep my sarcastic virtual assistant running. That sounds like a nightmare.
Well, if we connect this to the bigger picture, this is really the ultimate trade-off of the modern digital age. Sovereignty is not free.
The true cost of complete digital privacy is taking responsibility for your own infrastructure. I mean, for the last decade, we have happily traded our data and our privacy to massive corporations in exchange for convenience.
We really have.
They handle the servers, the updates, and the electricity, and in return, they got to read everything you ever typed. Running a local AI forces you to take that burden back. You manage the hardware, you pay the electricity bill, and you maintain the software. It requires effort, yes, but that effort is the literal price of keeping your digital life entirely your own.
Wow. So what does this all mean? We have gone from typing a single 5-minute install script in a terminal to building a fully uncensored, zero-subscription AI running right on your desk.
Yeah, quite the journey.
We've given it a personality, connected it to your WhatsApp, and wrestled with the realities of hardware, quantization, and the sheer exhaustion of being your own IT admin. In a world defined by constant, pervasive data harvesting, building your own local AI isn't just some fun weekend tech project for hobbyists to tinker with.
No, not anymore.
It really is a declaration of digital independence. You are taking your private thoughts, your work, and your data out of the cloud and putting them safely back in the vault.
It is deeply empowering. But, the blueprint leaves us with a brief tease at the very end that opens up an entirely new, almost physical dimension to this technology.
Oh.
Yeah, they mentioned the future integration of this local AI with Home Assistant, which is an open source software used to control smart home devices like locks, thermostats, and lighting. The guide actually jokes about the AI turning on the lights when you were in a bad mood.
That is both amazing and honestly slightly terrifying. I mean, it's one thing for the AI to read my texts, it's another for it to control my house.
But this raises an important question for you to think about. Imagine what happens when your highly personalized, totally private AI agent isn't just chatting with you on Telegram, but starts physically manipulating your smart home based purely on the emotional subtext of your text messaging.
Wait, really?
Think about it. It reads a frustrating text you sent to a coworker, mathematically senses your elevated stress levels based on your word choice, and autonomously dims the overhead lights, lowers the thermostat, and turns on relaxing music before you even walk in the door.
That is crazy.
If your local AI truly knows your emotional state better than you do, what will it decide to do to your physical environment?
Wow. An assistant that doesn't just manage your schedule or draft your emails, but actively curates the physical space around you based on your digital emotional state. And all of it happening securely, silently, inside a little box on your desk.
It's the future.
That is a wild thought to leave off on. So, to you, the learner out there, keep questioning the tools you use, take control of your data, and most importantly, stay curious. We'll catch you on the next deep dive.